Howdy folks, welcome back. So in this video I'm just going to quick go through the practice quiz and kind of give you an idea as to how I would go about solving the problems. Again, I recognize that my way is not the only way to go about solving these problems. So if you have a way that makes more sense to you and it gets you the correct answer, that's fine if you use that method. You don't necessarily have to use the method that I've talked about during class or in this practice quiz here. But yeah, this is just if you're kind of clueless as to where to start. Hopefully this will kind of lead you down the right path there. All right, so again, this first quiz is dealing with solving a linear programming problem. So kind of the three main parts when solving a linear programming problem. So the first question is dealing with the setup. The second question is dealing with graphing the feasible set. And the third question is, once you have the feasible set, actually finding your solution to the problem. All right. So this first one again is just asking for the setup. So here you have a truck traveling from New York to Baltimore, is to be loaded with two types of cargo. Each crate of cargo A is 4 cubic feet in volume, weighs 100 pounds, and earned $13 for the driver. Each crate of cargo B is 3 cubic feet in volume, weighs 200 pounds, and earns $9 for the driver. The truck can carry no more than 300 cubic feet of crates and no more than 10,000 pounds. Also, the number of crates of cargo B must be less than or equal to twice the number of crates of cargo A. So again, it's just this question is asking us to kind of set up the linear programming problem. So state the objective function and then the inequalities or constraints for your linear programming problem. All right, so starting off with the objective function. So in this case, we want to maximize our earnings. So our objective function is we want to maximize our earnings, which in this case we earn $13 for each bit of cargo A plus $9 for each crate of cargo B. So we have 13A plus 9B is our objective function, and we want to maximize that. All right, and then we have the constraints. So the constraints are inequalities, and the inequalities in this case are based upon the volume and the weight that our truck can hold. All right, so starting off with the volume, so each crate of cargo A is 4 cubic feet in volume, so we have 4 times A. So that represents the amount of volume taken up by crates of cargo A. And each crate of cargo B is going to be 3 cubic feet in volume. So we have 3 times the number of crates of cargo B is going to be the total volume taken up by cargo B. And in this case, it can carry no more than 300 cubic feet of crates. So this has to be less than or equal to 300. All right, so that's from the volume. And then the other constraint is from the weight. All right, so here we have each crate of cargo A is 100 pounds, so we have 100A. And then each crate of cargo B is 200 pounds, so you have 200 times the number of crates of cargo B. And the maximum that I can have is 10,000, so this needs to be less than or equal to 10,000 pounds. All right. And then we also have that the number of crates of cargo B must be less than or equal to twice the number of crates of cargo A. So you also have B is less than or equal to twice the number of crates of cargo A. And then again, we can't carry negative crates, so you also have A and B both have to be greater than or equal to 0. All right, so those are all my constraints, and then again, I want to maximize the earnings based upon those constraints. So that is all this question is asking for. So it's just asking for kind of a setup again. All right. So once you have your setup, the next thing is to graph the feasible set. All right. So this next question is dealing with graphing the feasible set. So it says graph the feasible set for the following linear programming problem. Minimize the objective function 3x plus 4y subject to the constraints given here. All right. So here we have, I'm going to denote this with the blue line. So this first one is going to be blue, And we'll go red for the second one. And we'll go green for my third inequality. All right, so in setting up the feasible set, the objective function doesn't matter. So we don't need to worry about that. That's just some extra information just to throw you guys off. All right. So we just need to graph each of these inequalities. And again, we shade the part that don't work. And then whatever is left, that's going to be our feasible set on there. All right, so this first one, so we have 2x plus y is greater than or equal to 6. So we can rewrite this in slope-intercept form just to make it easier for me to graph it, as y is greater than or equal to negative 2x plus 6. So we just subtracted 2x from each side to solve for y. All right, so we have my y-intercept is 6. And then my x-intercept, so if I plug in a 0 in for y, I'm going to end up with 0 equals negative 2x plus 6. So you'd add 2x, divide by 2. So we end up with a y-intercept of 3. And again, that's just how I would do it. You can also use the steepness property. So you can just go down 2 over 1. That will also be a way that you can get another point there. So again, there are several different ways that you can solve this. So I don't have a monopoly on that. So you don't necessarily have to follow the ways that I did it. All right. So yeah, so I'm just going to start off by graphing the lines, and then we'll worry about shading a little bit later. All right. So this next one here, so we have x minus or x plus 2y is greater than or equal to 4. So again, to get this in slope-intercept form, just to make it easier for me to graph, you subtract an x, divide by 2. So we have negative 1/2 x plus 2. All right. So that means my y-intercept is going to be at 2. And my x-intercept, again, if I plug in a 0 in for y and solve for x, I end up with x equals 4. All right. So that's going to be this line here. All right. So now I think we're ready to go ahead and start shading. So again, the fact that x and y both have to be greater than 0 means that we can't have anything to the left of my y-axis. And likewise, we can't have anything below my x-axis. Sorry. The way my camera is kind of set up, it's kind of right in the way. So if I end up hitting and shaking that, I apologize. All right. And then again, you can just choose a point in either half here. And if it works at that point, that means it's going to work for every single point in that half. If it doesn't, that means it's not going to work for any point. So again, generally, I like to use the origin just because, again, it's easier. It's an easy point to use, easy to kind of check. So if I plug in 0, 0, so if I plug in 0 in for x and 0 in for y, 0 is not greater than or equal to 6. So that means that that point doesn't work, which means nothing below the line is going to work. So you shaded everything below the blue line. All right. And we do a similar thing for the red line here. So again, if I plug in 0 in for x and 0 in for y, 0 is not greater than or equal to 4. So since it didn't work for that point, that means nothing below the red line is going to work there. So this is my feasible set. I need to get a different color here. All right. So yeah, so everything that's not shaded represents my feasible set for that. All right. And again, once you have your feasible set, the next step is to solve the linear programming problem. All right. So again, the fundamental theorem of linear programming says that the solution to your linear programming problem, so either the maximum or minimum value, if it exists, is going to be at one of your vertices. All right, so I'm just going to label this vertex A, this vertex B, just to make it easier. And this, so that's C and D. All right. So now we just need to find all my vertices. All right, so vertex A, so that's going to be the origin, so that's going to be the point 0, 0. All right, and then let's see. D is probably the other one that's relatively easy to find. So that's going to be your x-intercept of this line, the line y equals -4/3 x plus 100. All right, so your x-intercept again is when your y equals 0. So you multiply by 4/3, or we add 4/3 to each side, 4/3 x, and we multiply by 3/4. So 100 times 3/4. So that's going to end up being 75, 0. All right. And then for B and C, that's when you have to solve the equation. So it's slightly more complicated, but not too bad still. All right, so for B, that's going to be where 2x equals -1/2 x plus 50. All right, so we're going to add 1/2 x. So that's going to be 5/2x equals 50. So we're just going to multiply both sides by 2/5. So you end up with x equals 20. All right, so you're 20. And if x equals 20, that means y is going to equal 40. Again, you can just plug that into either of these two equations, and you should end up with the same thing. All right, so then to find the point C, now we're looking at these two lines. So the line -1/2 x plus 50 equals -4/3 x plus 100. All right, so I can add 4/3 x to each side, subtract 50. So 1/2, so that's going to be -3/6, and then 4/3 would be 8/6. So -3/6 plus 8/6 is going to be 5/6 x equals 50. And then to get x all by itself, you just can multiply by the reciprocal, or in this case, 6/5. So you end up with x equals 60. And then again, once you have that, you can just plug that into either of these two equations, and you should end up with the same thing, which in this case would be -1/2 of 60, so -30 plus 50 would be 20. And yeah, if you plug it into this other one, -4/3 times 60 would be -80 plus 100, which would also be 20. So, all right. So those represent our candidates, and then we just need to evaluate the objective function at each of those points. So if I plug in 0 in for x, 0 in for y, my objective function has a value of 0. If I plug in 20 in for x and 40 in for y, I don't trust my mental math, even though I should because they're integers, so it should be easy. I end up with 620. If I plug in a 60 in for x and a 20 in for y, I end up with 960. And finally, if I plug in a 75 in for x and a 0 in for y, I end up with 975. All right. So in this case, we're looking to maximize my objective function. So this is going to be my solution here. So the solution is haul 75 crates of cargo A and 0 crates of cargo B in order to get an earning of 975. All right, and there you have it. So again, that's just how I go about solving the problems. Again, if you have a way that makes more sense to you, by all means, you can do that as long as you end up with the correct answer at the end. Thank you guys. Have a great day. Talk to you later. Bye now.